Hello! Today I am going to talk about analog video recording. Previously we talked about analog television in general, minus the stuff about broadcasting, because we'll talk about that later in the communications class. But now we're going to talk about how this was recorded. So let's review real quickly the whole idea that we had a camera tube at one end of our system on which we were focusing an image through a lens. And this had a mechanism to scan that image electrically and turn that into an electric signal, which looked something like this. We had a voltage which was represented black. We had higher voltages that represented a certain amount of light being scanned across, and we had a pulse that went down to 0 volts and back up. That told the oscillators on the other side how to synchronize to keep our picture tube, which is recreating this image on a phosphor screen using an electron gun, painting the screen and taking this signal line by line. So here's one line, scans across, makes brighter and darker spots, synchronizes the oscillators, goes down a little bit, scans another line, giving us light and dark spots to paint the image that this camera tube is picking up over here. So now what we need to do is figure out a way to record this. So we talked about audio recording before, so I won't reiterate too much of that, but of course what we had then were basically reels of tape. Reel 1, reel 2, here's the feed reel, there's the take-up reel, and a audio head, and the tape would go across that head into the take-up reel. And we did discuss that with the record and playback heads of the time, depending on the gap, remember the head is a magnet. I'll just make it as a ring here, where there's a gap in the ring and a coil of wire, and that gap would give us a little place where the magnetic field would stick out and could record on that tape. And when we sent the tape back by there, the magnetic areas on the tape would cause a small current in this coil, and eventually we could recreate the audio. And we mentioned that with the gap width of the time and a speed of about 7.5 inches per second of the tape, we could get a good response for audio purposes all the way from 20 hertz, maybe 20 to 30 hertz, all the way up to 20 kilohertz. That was great, 7 inches per second. We also talked about that the smaller this gap, the higher the frequency we can put on there. So remember we talked about, here is our gap. And let me just draw the tape going closer to the gap here. And we could put spots about that big on the tape with a gap like that. And if we wanted to put them closer together, they'd overlap. But if we moved the tape faster, we could get those further apart so they wouldn't overlap. So the smaller the gap, or the faster we move the tape, the higher our frequency response would be. And like I said, at 7.5 inches per second, with the gaps of the time, we could get a frequency response up to about 20 kilohertz. So now we want to do the same thing, but instead of recording voltages that represent sound, which can go from 20 hertz to 20 kilohertz, we wanted to record something that could go from theoretically 0, but practically higher frequency. But for video, we're scanning a screen and getting information as we scan across that screen. And this process gave us millions of points of information over a very short period of time. And with broadcast television in the United States, I don't know about the PAL system in Europe, but in the United States, we needed to record frequencies up to 4 megahertz to get the resolution we needed for the standard video in the United States. So we need to record frequencies up to 4 megahertz, and so this gap size and that speed was not going to cut it. So we could improve a little by making the gap size smaller, but the real thing we needed to do is move this tape at lightning speed. And the first video recording experiments did use reel-to-reel recorders and did move that tape at lightning speed, but how long do you think that lasted? That tape would go through and maybe just a few short minutes 2, 3, 5, maybe 10 minutes at most, that tape would be used up, and a very expensive way of doing it. So what could we do? Engineers needed to figure out a way to move the tape fast, but not move the tape fast. How could they do that? Well, the idea came up, instead of moving that tape fast across the head, why don't we turn the head sideways and rotate it and move the head past the tape. So they developed the idea of having videotape, and I think that the transverse scan was developed first, but I'm not quite sure. But early attempts at videotape were for video broadcasting, so they wanted the highest quality, and what the industry settled on early was transverse scan, meaning that the head, if we draw the head here, it's a rotating head which had actually 4 little heads on it, so 4 video heads, so basically 4 gaps, and the tape was wrapped around something like that. And so we're looking at the tape side on. So coming off the reels, of course, the tape was flat, but went through a mechanism that curved the tape. So instead of moving the tape fast, we moved the head across the tape. And since the tape is moving and the head is rotating, we would actually end up with tracks across the tape in a diagonal path. And the early systems, each pass of this head across the tape would actually cover 16 lines across the screen. So here's our screen over here, and we have those lines going across, painting the image, and we would actually put 16 of those on each one of these little tracks here. So each head 16 lines, so one spin of the head would do 64 lines of television. And I remember in the days when this was the standard, sometimes if these heads were not the exact cleanness or they were not worn the same way, you would actually see on the screen slight differences in the appearance in sections. Each 16 lines would be a little lighter, a little darker, colors a little different, and you would see that in a repeated pattern. Every 4th one was the same. And that was a problem that happened with these early systems of scanning the TV lines in a transverse manner. That in a nutshell was how they developed the idea of scanning, where once again the head goes at a high speed, the tape goes at a fairly slow speed. I don't know off the top of my head the actual linear speeds of these tapes. I'll put it right up here, I'll look it up. But we would have the tape going across here fairly slowly, but the head going very fast and packing these lines very close together so that we could actually pack in that video information into this small area without having to have our tape stream by at an incredibly high speed. Then after that was recorded, it would go by an erase head on the edge, which would erase part of that. So we're actually scanning more than 16 lines. We have a little bit extra here that we can erase it. And then past that was a record head. So the tape is going this way. We scan the TV lines on there, then we erase part of the edge, and then we record the audio like standard audio tape in a track on the edge. We also did the same thing on the other side of the tape. Once again, we'll put the erase head here. And this one wrote in tracking information and digital information, at least in later ones, that could tell you where you were on the tape. So each time it scanned a whole frame on the video, which would be several of these lines, it would put a code on this track here saying what number frame that was. So it would number the frames and give you a number. And this was digital information once again. And it used what was called the SMPTE code. I'll talk about that when we get into computers and such. But basically it was a digital code on and off. And I'm not going to explain exactly how it worked because that's not important. But basically it was a self-clocking code where the width of the bits would tell you whether it was a 1 or a 0. Not quite so straightforward. For example, this would be a bunch of zeros, and this would be a bunch of 1s, and because of the way it encoded it, it would be self-clocking, so we didn't have to have any synchronization between the tape and the system's writing or reading it. And so no matter what speed you ran the tape through, it would be able to read the signal. And so in the editing process, you could run it through high speed, slow speed, and tell you what frame you were at, and you could stop it, and you could either cut it. They did actually cut the tape sometimes, or they're doing transfers from one tape to another, and the editor could tell the technician, stop at this frame, start at that frame, or whatever, by using these frame numbers. So we had the technical track, the information track, digital track, and whatever we want to call it there. And then we had the analog audio track over here. And of course, when stereo TV came out much later, I don't know if this ever did stereo. I don't know if it lasted that long, but we ended up with 2 tracks if it was stereo. But that's the basic idea of how videotape worked. I'm not going to go into a lot of details about how the electronics synchronized all these things, but the whole idea was, since we need to move that tape fast, but we don't want to move it fast, let's move the head at a high speed and lay tracks next to each other while we move the tape slowly to get this video information packed in a system that needs a 4 megahertz bandwidth to record that video. So that was what was used in professional systems, and something needed to be done to make this less expensive. This had lots of technical problems keeping the heads aligned. The tape, by the way, was 2 inches wide, so big, wide tape. I remember visiting a studio once and seeing this equipment. It's quite impressive. And they even had a cassette player, had video cassettes about this big, held 10 minutes worth of tape, and that's what they had the commercials in. And I'll see if I can put a picture up if I can find it, but if you can use your imagination, if I can't. And they had a carousel of these tapes that the technician, or they called them engineers, would stack in for the commercial breaks. So they would be running TV shows, and when the commercial break came in, they would push a button, or maybe it was even more automated, and it would bring up the right tape for the right time. So the technician had a list of what times certain commercials were supposed to run. They put the tapes in the carousel, or if you could call it that, in the right order. And then that would automatically pull up the right tape for the right commercial. But this is what they used in the studios. It was very expensive, tens of thousands of dollars for a piece of equipment. So what could they do to make it less expensive and especially bring it to the home market? And I remember in the 1970s at my junior high school, we had VTRs, videotape recorders. I don't remember if they were color or black and white, but we had videotape recorders there that worked on this principle I'm going to talk about now. And this is, of course, what was developed into home recorders. And eventually, the broadcast industry went to this type of system. And that was what was called helical scan. So once again, we have the reels, and we have a head, but instead of the head scanning transverse, it was kind of not quite parallel to the reels. The tape would come across, and that would have a guide here and a guide here. And on the systems that I saw in the 60s, you had to hand thread this, run the tape past that guide, and in an omega shape around the head. Now, if we look at this from the front, so here's the machine, here's the feed reel, and here's the take-up reel. Notice the take-up reel is a little lower, and the head is actually canted at an angle. That's probably exaggerated a lot, but as the tape goes by, notice that as the head goes around, it makes a diagonal track across the tape. And of course, this went around the entire omega shape. So the geometry was just right to make this scan across. So now our tape, which was half-inch tape, if I remember correctly, for the one that I had at my school. I've seen them with 1-inch tape, but the VHS system used half-inch tape. I don't know what the beta system used, but nevertheless, after running that around, they called it a helical scan, because instead of scanning directly across tape as the transverse scan did. Now remember, the transverse scan went straight across the tape, but the tape was moving, so we ended up with these diagonal stripes. But the helical scan would wrap around the tape, so we get a long diagonal stripe. And in this case, unlike the transverse scan, where each pass of a head would be 16 lines, In the helical scan, each pass was a single line. And one thing that I didn't mention before because, well, it really wasn't that important talking about video in general, but I'll mention it here. Because of broadcast restraints, which means I really need to talk about this in the broadcasting, we wanted to reduce the bandwidth of our signals. So we needed to scan this 50 to 60 times a second, otherwise there would be noticeable flicker. So in the PAL system, it's 50 times per second, basically synchronized with your power grid. In the Americas, it's 60 times per second, basically synchronized with our power grid. And so the idea is we scan this 60 times every second. The problem is the bandwidth for the radio transmission would be too wide. To squeeze it into less space and then have more channels, they would first scan the odd numbered lines, exaggerating my size here of course, and do that in a 60th of a second, so it's half the information. Then they'd scan it again, the even numbered lines, once again taking a 60th of a second to go across the screen. So it's taking a 60th of a second to go from the top to the bottom, eliminates the flicker, but we're only sending 30 pictures per second, and so the bandwidth for the radio transmission was half the width if we were sending actually 60 pictures per second. So we're sending 30 pictures per second, but we're scanning top to bottom 60 times per second. So the track on the tape would carry one line, so it would be like an even line, and then it would go again and scan the odd line. And some of them had two heads, although it didn't have to be this way. Cheaper systems had one head. And one head would scan even line, odd line, even line, odd line, even line, odd line. I know that I saw a system in the early 70s where it had only one head and only scanned the odd lines. Didn't even bother with the even lines. And so it was a half resolution vertically, basically. So the spinning drum had two heads on it. One would scan an even line, and just as it was finishing the even line, the other one would be partway through an odd line, so we'd get these very close, maybe partially overlapping. In fact, in VHS they do overlap, and they use a little trick to eliminate interference between them. And I'll mention that in just a second, but the idea is that we have these two spinning heads scanning even line, odd line, even line, odd line, and recording that information. And back to the VHS, those lines were so close together they actually overlap. So the heads, if we look at the drum, head number one is skewed that way. So the gap is canted, but it spins around the other side and we see the other head and it's skewed the opposite direction. So the fact that these magnetic fields were laid down cross to each other, they wouldn't interfere with each other, so there could be significant overlap of the tracks as they were laid down on the tape. And so if you look at an old VHS system, you might see something that says double azimuth. Cool. Yeah, all VHS were double azimuth. That's the angling of the head to lay that down on the tape. And like the original studio systems, this would have the edge erased after it was laid down by an erase head, and then another head would record the audio on the edge. So you see there's considerable overlap between these heads because this goes more than halfway around, and that extra space would be used to lay down the audio track. And of course it also had a track on the top to give synchronization information to go to the TV circuitry to make everything synchronize with the tape. It did not lay down the synchronization information as far as I know, so that synchronization pulse that comes before, I don't believe that was put on the tape. That was put on the technical information track that was on the other side of the tapes, very similar to the transverse scan. And so that's in a nutshell how the VHS worked. As far as beta is concerned, it worked very similar to the VHS. I don't really know the technical differences, other than they moved the tape a little faster so the tracks didn't overlap as much or at all, and were able to develop a higher quality signal. And so beta was better than VHS. But the big problem was that you could take a standard VHS tape, you could record for 2 hours. Beta, you could only get an hour. And so people wanting to record TV shows and time shift them VHS was better if you didn't mind the lower quality, and so Beta basically failed in the market even though it was a better system. But Beta was used a lot in the broadcast industry. And this system, mostly in the form of Beta, but maybe some other systems too, they switched from the Transverse scan to the Helical scan in the broadcasting systems too. And while I'm at it, later on they added high fidelity stereo. Early stereo tapes had 2 audio tracks on the side, and they're just regular analog tracks. And of course this tape's moving very slowly, and so the quality of the sound was limited. So they developed a way of mixing in the sound with the video tracks. I don't know the exact technique, but they mixed it in such a way that it had minimal interference with the video, and they're able to put 2 high fidelity audio tracks mixed in with the video. And so that was, some of the later systems had that rather than just the audio tracks on the side. So later tapes would have the regular analog audio tracks plus the high quality tracks that went on with the video. So once again, there's a video on The Secret Life of Machines that talks about video recording. In fact, it's the same one that talked about audio tape that I gave you the link to a part of earlier. And I'm going to put a link here to the whole video because the video is actually about video recording. And so that's certainly a good video, has good visuals, much better than I can do on my little whiteboard here. And so I highly recommend watching that Secret Life of Machines. And so here is the link. So that's the basics of how video recording worked in the days of analog video, and I hope you found that useful and informative. And if you did, please give me a thumbs up down below. It really helps the channel. And if you want to learn electronics technology and perhaps become a certified electronics technician, or just get a jump start in your studies in electrical engineering, or maybe you just want to learn electronics because you just want to, you can go take my free class at Vocademy.net. You can find all the reading material there, plus links to the videos to take my full course. And Vocademy and these videos are sponsored by you. I could not do it without your support. So to help me make these videos and keep Vocademy free, you can go to patreon.com/Vocademy and pledge your support, or to make one-time donations, you can go to paypal.me/voced, V-O-C-E-D. And if you can't afford to donate, you can help me by subscribing to this channel, giving these videos a thumbs up, and commenting below the videos. All of those help the algorithm to help other people find these videos. So a big thank you to my patrons and one-time donors. I couldn't do this without you, and thanks to everyone for watching.